We shall overcome, we shall overcome, we shall overcome someday. Oh, deep in my heart, I do believe we shall overcome someday. We shall overcome, we shall overcome, we shall overcome someday. Oh, deep in my heart, I do believe we shall overcome someday. We walk hand in hand, we walk.
Dear students, welcome to our online class. I'm Mahedul, Assistant Teacher of IGS, International Grammar School, Rampur. Today we will discuss about Chapter 5, State of Matters and Pressure. This chapter will discuss for both of Standard 9 and 10. So, firstly I am going to write down the name of this chapter. This is Chapter 5, State of Matters and Pressure. So, states of matters and pressure. Though the student of class 10 already know this about this chapter, but for standard 9 probably this is the first time you have hearing this name, pressure and state of matters. If we look at the name of this chapter, what you will see that the pressure is a new thing and a state of matters. So we are going to discuss about pressure. If I ask you, can you define me what is pressure? Probably yes or probably not. Firstly, the most interesting thing of physics is you don't need to define it by according to your book. You can define it by your as pressure. What do you mean by the pressure? In Bangla, the chap. Okay? So pressure, here pressure, but already you know the physics and natural things, these are totally different. So if I want to define a pressure, that will be, pressure is denoted by P and P equal F by A. P equal F by A. What is P, F and A here? P is standing for pressure. F equal force and A equal area. So we can easily define pressure now. Applied force on an unit area is known as pressure. I'm repeating again. Applied force, that means the force we are applying in an unit area, that means 1 meter square space, that is pressure. So we have to know what is the unit of the pressure. The unit of the pressure. What is the unit of the force? It's Newton. And area, Newton meter square. That means it will look like Newton per meter square. So Newton per meter square is named as the unit of the pressure. If we want to define it again, if we apply force on an unit area, that will be pressure. This Newton per meter square is not SI unit. Do you know what is SI unit? SI unit, that's not the sub-inspector of police. SI, that's not sub-inspector of police. That SI is a standard unit, international, that means international unit of. This SI is standing for International Unit of System. Okay, so what is the SI unit of pressure? That will be Pascal. That will be Pascal. So we already got two types of units, Newton per meter square and the Pascal. Which one is needed? when we practice the maths, the unit will be, we should write the SI unit. As you know, the SI unit of for pressure equal Pascal. Now you can ask me, sir, if I ask you, what do you mean by 10 Pascal? 10 Pascal equal what? What do you mean by 10 Pascal? The answer will be, okay, we can easily write down this way. So 10 Pascal equal F by A, and as you know, from the definition of pressure, unit will be 1, that will be the force, equal 10. That means F equal 10 Newton. Which one is showing you? If we applied 10 Newton of force, what I told you, if we apply 10 Newton of force on an unit area, that means 1 meter square area, that will be 10 Pascal. Okay? So this is 10 pascals. Now I am going to show you what is the dimension of pressure. Obviously there is a dimension, and what is the dimension? As you know, dimension, you can easily find out the dimension of pressure. So let me show you how to find out the dimension of pressure. As I told you, P equal F by A. Now what is the force? Force, you can define force F equal ma by A. Again, A equal acceleration. So the dimension of mass equal capital M. The dimension of acceleration is LT inverse 2. LT inverse 2, and the area equal L square. So that will be ML inverse 1, T inverse 2. So the dimension of pressure equal ML inverse 1, T inverse 2. This is the dimension of pressure. Okay? So that is pressure. All over the pressure, we have find out the unit, we have find out the dimension. Now just we are going to solve a simple mathematical problem. What is that? Suppose 10 Newton force is applied on 2 centimeter square area. What will be the pressure? So easily you can solve the math. How? Look at that. Centimeter square. This is the area. 2 centimeter square. Firstly, you have to convert this centimeter square to meter square, and then 10 Newton is Newton. This is the unit of force. So when you solve this math, firstly we have to write down that here F equal 10 Newton, A equal 10 centimeter square. Just convert it into the 10 by 100 square, 2 meter square. Okay, the value will be given, and we know P equal F by A. Just put the value here and the problem will be solved. Okay, hopefully you will try it by yourself. Okay. Now another things I have further to tell you, that we will look at the equation of pressure again. What is that? P equal F by A. P equal F by A. What is that equation means to us? Look here, if the force is increased then the pressure will be increased. On the other hand, if the area will be increased, then the pressure will be decreased. I am giving you a simple example. Suppose a girl is wearing a high heel or the pencil heel. Already you know what is the pencil heel? Okay, suppose that a girl is wearing a pencil heel and she pounds on a leg of a boy. That will be so pathetic because of the area of that heel or the shoe is so tiny, and when the area is decreased, the pressure will be increased, and that's the reason that person will feel the larger pressure. On the other hand, if the force is increased, suppose a girl is wearing a flat shoe, okay, and the weight of that girl is 50 kg. If he punches a boy or a person, here her pressure will be a certain pressure, and when another girl of 60 or 70 kg, when she wears that type of flat shoe, that means same area of that flat shoe, and when she punches, her weight will be increased, that means force will be increased, and then the pressure will be too much increased. So in the summary, we can say that the pressure is depending not only the force but also for the area. If the force is increased, for the fixed area, the pressure will be increased. Again, if the force is constant but the area is decreased or increased, the amount of pressure will be increased or decreased. How? It's inversely proportional. How? If the area will increase, then the pressure will decrease. If the area will decrease, the pressure will be increased. Now we are going to discuss about another topics, that is the density. Very interesting things, density. So let me show you what is density. Can you tell me, you can know what is, do you know what is the density? Density. Density is denoted by rho. Probably this is a new word to you. This sign is known as the rho. Rho. So we can write down rho equal m by v. Rho equal m by v. What is rho here? Rho is density, m equal mass of the body, and v is the volume. Here you shouldn't say that the v is velocity. As I told you, this v is not velocity here. So what is this v? This v is volume. Volume of any object. So we can easily write down the rho equal density, m equal mass of the object, and v equal volume. Look at here. If the density if you want to find out the density of any object, that will depend on the mass and the volume. If the volume is increased, then the density will be decreased. If the mass will be increased but the volume will be fixed, the density will be also increased. I am giving an example. Suppose you have a glass of water. So the volume of that glass is fixed, and you have filled up this glass with water. Now you will start to put some sugar. Suppose you are just putting 1 spoon by 1 spoon by 1 spoon randomly. After some times you will see that that water of that glass looks like sticky. That means the density has increased. The density has increased, but the volume is unchanged. Okay, as I told you, the amount of water, that means the volume of water or the glass will be unchanged, but the density has been changed because of, you have seen that the water becomes sticky. How it's possible? Because of we increase the mass but not the volume. We haven't changed the volume. One glass of water was there for the first time, and the last time the one glass of water was still there, but we have increased some amount of sugar. That means the mass has been increased. That's the reason density has increased. On the other hand, suppose you have a bucket of water and 10 or 15 spoons of sugar there, and you start to heat up that water. After a certain moment, the layer or the amount of water will be decreased. Again, that will make it sticky. What is happening there? The volume is decreasing. By having heat energy, the water becomes water vapor, and the water amount of water has been decreased, the volume has been decreased. That is the reason density has increased. So already we have known about the density, how the density will be increased, how the density will be decreased, and what is the condition to increase or the decrease density. Hopefully we'll understand easily. Now we are going to discuss a new topics. Just let me show you a magical topics that an equation P equal H rho G. P equal H rho G. So we have to establish this equation. Okay, just I am going to show you a figure. Suppose it's a beaker and totally filled up with water, and here's a cylinder. The height of this cylinder equal S. The height of this cylinder equal S, and the pressure is applying on that cylinder. We will just find out the amount of the pressure here. Okay, how we will do that, and how we can prove that equation P equal S rho G. Already we know the equation of pressure P equal F by A. P equal F by A. So here we know F equal force, A equal area, and P equal pressure. So we can easily write down that P equal mg by A, where m equal mass, g equal gravitational constant, acceleration due to gravity, acceleration due to gravity, and A equal area. So what we have got? M equal mass of the object, G equal acceleration due to gravity, and A equal area. Okay. A few moments ago, we have learned that another equation which is rho equal m by v. Isn't that? Rho equal m by v. So we can easily write down m equal rho v, m equal rho v. So we will put the value rho v into g divided by a. So rho v into g divided by a. Okay. So what is v here? V equal volume. Already we know the volume equal, you can write down the volume V equal length into breadth into height. That means area into height. We can write down the V equal area into height. V equal area into height. So we are putting the value here. What will be that? Area into height into rho into G divided by A. So cancelling A and A here, we can easily write down that P equal H rho G. That means this P equal H rho G. What is that equation? P equal H rho G. So P equal H rho G. That means we can say that pressure equal height into rho, that means density into gravity, acceleration due to gravity. What is that? We can write down pressure equal height into density into acceleration due to gravity. So that is pressure, height into density due acceleration due to gravity. Now the most interesting things, I am showing you the another interesting things, that is P equal H rho G. Look at the equation P H rho G. The interesting thing is there is no mass here. No. So P equal H rho G. That means if the height will be increased, then the pressure will be increased. If the density will be increased, then the pressure will be increased, and the acceleration due to gravity is a constant thing. Suppose the height is fixed and the gravity, acceleration due to gravity, both are the fixed. Then what will be happen? P is proportional H. We can say that pressure is directly proportional to the height. When that will be happen if rho and G is constant. If the rho and G is constant, that means density and acceleration due to gravity is constant, then we can easily write down the P is proportional S. That means if the height will be increased, then the pressure will be increased. If the height will be decreased, then the pressure will be decreased. That is the most important thing. Sometimes this type of question can be, you can get in your exam paper, that means question paper. So what is the relationship between force and height? So this is the relationship between pressure and height. When this pressure and height relationship will be established, when the density and acceleration due to gravity will be constant. So that was all of your today's task. So a state of matter and pressure, what we have learned from today's lecture. Now we are just going to summarize that. That means in the summary, what was our today's lecture? We have discussed about the pressure, we have discussed about the density and the unit and dimension of the pressure and density, and we have established a relationship that is P equal H rho G. Now last and most important things, do you know, we all the human beings, we are feeling a pressure. Which type of pressure? That is the air pressure. Suppose I am here, the air surrounding me is giving me a pressure. You will be astonished to know the amount of pressure is near about the weight of a small elephant. That means if I put a small elephant on your head, you will feel the pressure, that type of pressure is giving in our body. But unfortunately, we are not feeling that type of pressure. How it's possible? Because of in our inner body, we also have some pressure. That is the blood pressure, the pressure from our lungs, and the both side pressure is equilibrium. That's the reason we are not getting that type of pressure. Hopefully, the lecture you have learned well, and we will enjoy that lecture. Okay, we will meet you next time. And in this corona pandemic, hopefully, and I will advise not to go here and there. If you go emergency, must be use mask, sanitize your hand, and keep well, take care of